So hey everybody, this is Chris here, and I'd like to introduce you to my research on hierarchical color learning and convolutional neural networks. So there's been a lot of research over the years that suggests that humans have some hardwired preferences for certain colors over others. This has been shown in eye tracking studies, infant color categorization studies, and also just in human language, which is the most kind of well-known example of a color hierarchy of preferences for certain colors over others. So the human color hierarchy in language suggests that if a language has a term for certain colors, let's say blue, they'll also have terms for all colors to the left of it in this figure. So in this case, yellow, green, red, black, and white. So will neural networks display similar hierarchical color patterns? This is actually a reasonable question to ask because research has shown that there's similarities between CNNs and biological vision, both in terms of the inspiration behind their architecture, the internal representations learned in both systems, and also the color selectivity of certain neurons in both human vision and CNNs. So we investigate hierarchical preferences for colors in neural networks over two experiments. The first experiment is the CNN color classification recall experiment. This experiment is designed to investigate whether CNNs are able to learn certain colors faster than others. So the dataset used for this experiment was just basic images downloaded from Google Images for these 8 colors: blue, brown, green, grey, orange, purple, red, and yellow. The model that we use in this experiment has been shown to learn colors effectively in the past. What's important to note here is that this CNN model that we use in this experiment has 5 convolutional layers, which has been used in the past for other studies which investigate similarities between CNNs and biological vision. So for the methodology, we trained the CNN to classify colors into one of the 8 color categories that we outlined before. When recall for a color category was greater than 0.85, we would record the epoch at which this was achieved and maintained, and we would say that the CNN successfully learned this color. This was repeated 500 times for 5 different color spaces, some of which are the standard input color spaces like RGB, BGR, and then other ones like opponent spaces or these luminance based color spaces are more biologically inspired color spaces. And then we use ANOVA to check for statistically significant differences between the learning epoch for the different color categories. So this figure here summarizes the results of the experiment as determined by ANOVA. So this less than sign here indicates that the colors to the left were learned significantly faster than the colors to the right. And we can see definite similarities between these results and the human color hierarchy, where across all color spaces, red was learned fastest. Colors like yellow, green, and blue were kind of learned in the middle. And then last was brown, gray, and orange across all color spaces. So the second experiment that we did, the faster or CNN clothing recall experiment, investigated how clothing color would affect performance on object detection tasks. So the dataset that we chose for this experiment was the MojaNet fashion dataset. This is because we were looking for a dataset with lots of different color objects that had completely different colors. So clothing seemed very appropriate for that because clothes come in all sorts of different colors. For the methodology for this, we just used a faster RCNN with a ResNet 50 backbone and a feature pyramid network. We continued to train the model up until the MAP score leveled out at around 70%. And what we did then was, once we, for the test data set, we divided clothing items based on 2 other subcategories. So, which is basic color, such as strong red shirts, moderate red shirts, we're all just classified as red shirts. And then also we have another sub-labeling for descriptive adjectives, where we say strong yellowish pink shirts, strong red shirts, we're all classified as just strong shirts. And then we calculated recall scores for each of these subcategories that we created for each clothing object. And when we look at the results, similar to experiment 1, red shows the best recall. And then colours lower down the hierarchy, such as brown, orange, and grey, show greater than 10% worse recall on average than these colours higher up the hierarchy. And also, interestingly, colours that are described as vivid, brilliant, or deep, so colours which emphasise you, generally show much better recall than colours which de-emphasise you, such as moderate, light, or pale. When you look at both experiments together, both experiments showed hierarchical preferences for certain colours over others. Furthermore, these hierarchical preferences followed a pattern similar to the colour hierarchy, where red showed the fastest recall and best learning in both experiments, followed by green, yellow, and blue next, and then worst recall and slowest learning time was for brown, orange, and grey, which is at the bottom of the human colour hierarchy. So thank you for listening to the presentation. I hope you enjoyed it. Enjoy the rest of the conference.